Introducing the McCormick Systems Estimating Suite. Hands down the easiest and fastest estimating system on the market. From PDF to proposal, all in one program. The estimating software has 4 levels, each packed with more and more features. Also, add on our famous on-screen Estimating Pro. McCormick definitely has the right software for any contractor, small to large. Welcome to the ease and speed of McCormick estimating. Let's take a look at the software. Let's go ahead and click the New Job button. This brings us to our Job Details window. Simply fill in the information about the job. Details are customizable and can be used to fill in our automatic Microsoft Word proposals at the end. Final step, add your drawings to the job so we can take them off later. McCormick will accept pretty much any type of file. Grab your PDFs, TIFFs, JPEGs, whatever you'd like. After loading them into the job, you can pick and choose which drawing you'd like. Simply preview the drawing first and then click to save it. Let's go ahead and grab all of these drawings and import. That's starting a job. We're ready to estimate now. The process is easy and straightforward. We're going to follow 5 simple steps. We've completed step 1 and started the job. Let's go ahead and click on step 2, Labels. Labels are McCormick's way of breaking the job down for project management. First, we can name the different types of bids for this particular job. I'm going to go ahead and add in a couple alternates, and then later on we could do change orders too, all under the same job. This particular job has 3 major sections, so I'm going to go ahead and add those to column 2. Now I want to break up those 3 sections into column 3 by the floors. This way, if I wanted to, I can run a material list on, say, Building B Floor 2 later on down the road. We give you the opportunity to break out a job however you'd like. Now let's go ahead and do the takeoff for those breakouts we just did. You can see here all of the labels we just provided. Now all we have to do is click on the label we want to work on. Let's work on Base Bid Building A Floor 1. McCormick has thousands of preloaded items and assemblies. Let's go ahead and check out an assembly that we already have built. In this example, we're going to look at a water closet. So if we click on the water closet, we can easily just count how many we want manually. This shows that I've taken off 10 water closets manually into my audit trail. Check this out. In this assembly, by counting the 10 water closets, I get the water closet and all the pipe vertical in the wall. Waste, water, and vent is done in one button click. Assemblies are totally customizable. Use McCormick's preloaded assemblies or change or build your own. Finding things are a snap also. Let's check out some pipe. Let's run some copper 95.5. With this assembly, I'm going to use a band hanger with C-clamp. Let's go ahead and click on this 1/2 inch. And let's say we need 500 feet of this pipe for this job. Just type it in and hit enter. Here's another way to view an assembly. Click the down arrow to view exactly what you took off. With that 500 feet, I'm automatically going to get all of my copper tube, all of my couplings, all of my solder joints, C-clamps, band hangers, and so forth. With McCormick's assemblies, takeoff has never been faster or easier. Let's do some takeoff for floor 2. Notice how the audit trail is empty? That's showing that we've not done anything for floor 2 yet. Floor 1 still has its takeoff in there. McCormick's easy to view audit trail keeps you organized, shows you exactly where you're doing takeoff at all times. Okay, let's show you how these assemblies now relate to our digital on-screen estimating pro takeoff. This assembly here can be assigned a shape and a color. I've made this an orange line. Alright, so instead of us doing manual takeoff now, we're going to go ahead and open up a plan. Let's start doing some digital. I'm going to go ahead and pick my plan. Once I pick my plan, I can choose to rotate the plan if I wanted to, and I must pick a scale for us to do proper takeoff. That's how quick and easy it is. We're now ready to start doing our takeoff. So I'm going to take that orange line, or that 1/2 inch copper, and start drawing it on my plan. And as you can see, it is measuring and saving every piece of takeoff for me. All I have to do as an estimator, draw it on the plan. Measurements and takeoff automatically drop into the audit trail. Let's take off some more material. Let's go ahead and grab a lav. We're gonna go and pick L copper coming in, and we want PVC going out. Let's go wall hung. Again, you can see all of the parts and pieces we need to install that. And our OSE Pro specs show it's a blue lav. Again, all we're gonna do is place that lav right onto our PDF, and the program automatically counts it. Now we can rotate and size our shapes as we're doing takeoff. This is super handy for when we're doing our design build. Remember, with design build, you can place these symbols anywhere on the drawing that you'd like. Okay, let's go ahead and take some water closets off. Same thing, we're gonna go L copper water in and PVC going out. Again, grab the plan and place the water closets where they belong. Last but not least, let's go ahead and grab our waste pipe. We're going to do some PVC drain, waste, and vent, and we'll go no hanger since it's underground. Let's grab the 4-inch and place it on the drawing. Again, since each fixture already has the vertical built into it, all I have to do is draw the horizontal. This digital takeoff sure does make estimating fun. But besides it being fun, you can see that it lessens the opportunity for mistakes and keeps you more consistent for every plan, for every job. Again, every pipe run or every fixture is auto-saved. As soon as I mark it on the plan, I am done. Okay, so all of this takeoff that we have done is now loaded into the estimating software audit trail. Notice the P on the right hand side. This is showing that it's coming from the plan or OSE Pro. Here's where it really gets easy. When you're done with your takeoff, hit number 4, extend, and automatically you've got your material list totaled up with price and labor units. Let's go ahead and look at one of our pieces of material. We took off that 1/2-inch copper tube. It looks like we took off about 1,396 feet, and our price is $1.03 each foot. If I wanted to, I could change the pricing right in the material list without affecting my database. Let's say I wanted to change it to 98 cents a foot. No problem. Also want to change my labor unit from 0.03 man-hours each foot to 0.02 man-hours each foot. You can see in the bold everything that has been changed on this material list. Watch this, I'm going to collapse my cost codes and you can now see your totals for every cost code in the system. Look at my copper, I've got $1,395 total cost and 49 man-hours. You can easily see the material list by clicking on the arrow. Remember those labels we set up before? Now I want to see my material list by floors. Let's go ahead and separate out the floors. Now when I collapse my labels, check this out. You can see my floor 1 total material cost and man-hours. Same thing with floor 2. Anytime you want to see the material, just go ahead and expand that label. Breakouts, bid review, material ordering, and project management are unmatched in McCormick's extensions. Now we can send a summary and finish up the bid. The bid summary is an easy place for us to finish up the bid. We have our total material cost here, and we're now going to add our labor to our man-hours. Keep all of your workers' rates in the system and simply add them to the job, or bid with a composite rate. In this example, I'm going to give 20% of the hours to the foreman, 40% to the fitter, and the other 40% to the apprentice. All hours have been assigned, giving you total labor dollars. Flip to the Quotes tab to easily enter quotes from your suppliers as you receive them. We'll enter in a few quotes here, and you can also add more lines if you need. Adding subcontractors are just as easy. Let's throw in a couple here. Next, we have our direct job expenses. Let's throw in some permits and fees, and let's grab a couple $100 for some fuel and oil for this job. If you want to charge for some equipment rental, go ahead and add that in. We also provide a bonding table and of course your taxes. There you have it. We go to our top sheet and view all of our totals. If we look down the right hand side, you can see your full job totals. Now we just need to make some money. Let's throw some overhead on here. Here's 10%. I can add it to all of my categories and then simply change individual categories if I choose. Same thing with profit. Let's go ahead and add 25% to all of our categories. Now we can add the square feet for the job. This will give us a price per square foot and hours per square foot. Not only that, let's go ahead and add in job months. Say I want to get this job done in 1 month and we work 40 hours a week. That will give us 1.23 workers per day that we will need to complete this job. That is how fast and simple it is to complete a bid with McCormick estimating software. McCormick has many more extras like an automatic Microsoft Word proposal, schedules, graphs. Give us a call for a full, complete web demonstration. Now that you've seen the future of estimating, why waste countless hours on an old way? Give us a call.
So let's think about waste pipes for a minute. Imagine you're standing in a bathroom in a building and you're looking down to the sink, you're about to brush your teeth or wash your face, and the pipe was laid out the way it's drawn here. So the pipe went down from the sink and then into the wall and then down the pipe and then eventually to this sewer pipe out in the street. What would be the obvious problem with this? Well, clearly the obvious problem is I'm going to be getting sewer gases right up from that pipe, straight from that sewer pipe in the street. There's air is essentially filling most of this pipe until there's some wastewater that's flushed down it. So if that air is just sort of open pipe, that means that's an open pipe all the way to the sewer line, which clearly would be a really foul-smelling element. Now, if that was going to the outside, it probably wouldn't be a big deal because the air would blow it around and you wouldn't even notice it. But if it was going into a small room, like a bathroom or a kitchen or a bedroom or a laundry room or something like that, that room would fill up with the sewer gas very, very quickly and it would be just unlivable. So what do? How did people figure out how to deal with this? Well, they kind of came up with this very simple and clever idea, which was the trap. So instead of it going straight down, there's a little trap there. There's this little P-shaped element that then creates a spot where water will fill up in the trap and create a block, essentially traps the sewer gases from being able to get out through the sink. So that shape then does something like that, where the water fills up that bottom part of the trap and therefore the sewer gases can't get passed through. People often assume that the trap is actually there in order to trap like wedding rings and things like that fall down the sink. That's a handy addition that you can get out of a trap. It also stops sort of a filtering system, stops some of the gunk from getting into the main system and causing problems elsewhere. But the main purpose of it is to trap the water that then traps the sewer gases from coming out into the space. So as I said, this is a really clever idea that somebody came up with hundreds of years ago. And I know I would have thought of trying to do some sort of mechanical closer or something like that. The idea of just using the water itself, I think, is just really an incredibly smart idea. But it has a couple of drawbacks. One of the drawbacks is If I have a whole series of sinks or toilets or whatever, one floor after another, if you imagine that, say, this sink fills up and you're washing dishes or doing something, and now you're going to let all that water go, and it's going to go rushing down that pipe as it goes down that wall. Well, there's air in front of it and there's air behind it, right? There's only so much water that's filling that pipe, but it's going to fill the pipe up. And so as it rushes by, it's going to push the air that's in front of it out of the way, and it's going to pull air behind it. Because something is creating a vacuum, something has to reoccupy that space. So if you imagine that water flowing down very quickly down that pipe, as it rushes by and it needs to create that vacuum, it has to pull some air in to fill that space, that void in the pipe. What's it going to do? Well, it's going to just siphon that trap and pull that water right out. So as that water from above is rushing by, it's just going to siphon this water right out of the way and to follow the water from above, sort of flushing right on through. So therefore, if I have a whole series of these things stacked one on top of the other, multiple floors, very quickly the traps are going to get siphoned clean, and therefore I'm going to have that exact same problem of that sewer gas smell coming back up through. So, what do you do? The traps seem like a brilliant solution, but it's missing something. Well, what's it missing? It's missing a vent pipe. So a vent pipe is a system where at the top of every fixture, there's not only a pipe that goes down to the sewer, but there's also a pipe that goes up to the roof. Once it goes up to the roof, opens up to the sky, and therefore, when the rush of water goes by, when that siphon wants to happen, instead of pulling the much heavier water out of a trap, it's going to pull much lighter air from the roof. And so that air is going to fill in that space behind the rushing water much more easily than it would to pull all that water out of this, siphon all that water out of the trap. So what this means is kind of counterintuitively. If you walk through buildings, you've seen all this a million times probably, but just sort of worth mentioning that when you really start adding up the number of linear feet, you probably have more linear feet of vent pipe than you do of actual drainage pipe. There are vertical pipes going up from the fixtures that are solely filled with air all over the place. Now, this brings forth a number of different issues. One is that the waste pipes will sort of, by the nature of it, kind of clean themselves. They, as water flows through them, as even wastewater flows through them, there's sort of a natural process where they're sort of clearing themselves out. They get clogged and other things happen, and things need to be maintained. But there's sort of a general process of those things sort of clearing themselves through as long as the gravity is running correctly through the pipe, and the pipe is always sloping downhill. The vent pipes, however, have this very acidic and problematic air in them. And that acidic air, as it goes up and flows towards the top of the vent pipe, will eventually start cooling off and condensing some of its very acidic moisture that's in there onto the walls of those vent pipes. So the vent pipes actually tend to also, not only are there a lot of vent pipes, they tend to actually deteriorate before any of the other pipes. So if you're having to do any maintenance work, the vent pipes are almost always the first thing that has to be maintained. You also have to make sure that the vent pipes are sloped in the opposite direction so that as that condensation, that fairly unpleasant condensation, starts to find its way to the walls of those pipes, there's always a way for it to drain back down and eventually find its way to the main waste pipes. So everything is angled in such a way as to always be draining positively. Now, there's a lot of different specific ways that you can vent different fixtures. We're not going to really get into all the detail right now, but that is one of the things you might want to be looking for, is some of the sort of fancier, trickier ones. it's hard to know what they would ask a question about, but for now we're just going to talk about the general basic ways that, that the venting and waste piping works. So we have the idea of a plumbing fixture, say a sink or a water closet or a shower. Each one of those is going to have a drain pipe. That drain pipe is going to have a trap that traps the wastewater in it, so that that wastewater can become a trap for the sewer gases. Each one of them will then connect to a larger system that eventually gets out to the sewer in the street. And each one will also have a vertical vent pipe that goes upwards towards the roof or some outdoor outlet. That doesn't mean that each individual pipe goes up through the roof. They usually gather together and collect up, and then only a few pipes go up through the roof, because it's always a bad idea to have a lot of holes in your roof. So you want to have as sort of few of those vent pipes actually penetrating through as possible. And so you often end up with kind of intriguing looking diagrams that have multiple elements coming all through, and they're all venting upwards until they get to that roof element. Now, sometimes when people talk about this, they say, really, if you just have the open sewer going up to the roof, doesn't that make everything smell bad? If you actually go up onto a roof, you can actually usually smell it a little bit. You can tell there are vent pipes that are connected to the sewer. But because you're up on the roof and the wind is blowing and there's big open sky, it doesn't really matter. It doesn't build up in any way that would be uncomfortable for anyone, unless there's a very peculiar way that the air moves in that particular space. So in general, it's not a problem at all, but it would be a problem if it was going into a room, if it was going into an enclosed space, or even potentially a courtyard. A couple of other terms to mention. One is the idea of a clean out. You will find that every place that the direction changes on any waste pipe, any major change in direction, there will always be a clean out. That means there's some spot where the pipe continues the opposite direction for just a second, and there's a cap on the top, and you can spin that cap off and get a clean out rod in there and clean that whole thing out. So at the bottom of all the verticals, at any major 90-degree turn or any other kind of strange shape in the pipes, even pipes that are straight but go for a very long way, you might have multiple clean outs along it, just so that you had the ability to figure out where there was a problem and to be able to get to it with a rodding system or whatever else you needed to do. This may not seem like a big deal, but if you have a clean out, it also means you have to have access to the clean out, which means that there has to be an access panel if it's not readily exposed into the room. If it's hidden behind drywall, there has to be an access panel. Well, if that happens to be in the middle of your main lobby or in the living room or in the conference room or something, that can be a big deal. So thinking about where those cleanouts go, thinking about how the system's going to work, is actually kind of a design decision, even though it seems like it's only a systems decision. So that's one of those kind of unusual ones you have to be a little careful about. So every fixture will have that trap, and every fixture will have that vent pipe going up to the roof. They might go up by itself, it might connect over to another one, but all of those things will be interconnected, both going down and going up.